There are several system catalogs that provide information about assemblies and the code modules installed within a database. With access to this information, it makes it easier to maintain the code base within a database. All of the catalogs are available by using regular select statements like these. Okay, so I'll execute these one at a time. So here's sys.assemblies. Oops, it would help to change to the Northwind database, and I'll execute that code again. Okay, so this shows all of the assemblies and information about them that I've installed within the Northwind database. So probably the most important piece of information is the CLR name field right here, because this has the unique name of each assembly. This is defined by the .NET framework. But it also has the name that we installed the assembly as well as some principal information, an assembly ID, as well as the permission set for each of the assemblies. And what's kind of interesting here is that it also includes the Microsoft.SQL Server types assembly. So this isn't something that I installed, but because we're using SQL CLR code, Microsoft needs access to that types because it defines the data types, the SQL data types that you can use. And so it needs to be available for access from the SQL CLR code. All right, then the next one is sys.assembly files. And there you can see a list of the files in the database. The assembly ID value is a foreign key back into the sys.assemblies table. So you can link these files with the assemblies that they belong to. And the number of files listed depends on how you deploy the code to the database. If you simply use a create assembly statement and then load the DLL file, that's the only file that's going to be included. And as you can see, it doesn't include the DLL extensions here. But if you use Visual Studio to deploy the file, you'll also get these debugging symbol files. And in older versions of SQL Server, you actually got the source code files as well. Now, if you're not using Visual Studio to deploy assemblies to a database, you can use the alter assembly statement here, like this code right here, in order to add a file. So I have a text file there at this location, and so I can go ahead and execute that code. That executes successfully. And now if I re-execute that line of code, you can see that I've added a custom file that is associated with a particular assembly. And specifically, it's associated with the SQL CLR assembly. So this is a handy way. If you wanted to include all of the source code files associated with an assembly so that you have everything necessary to rebuild the assembly, you can put it into SQL Server so it's all in one place. And then, if you wanted to view the source code, you could do something like this. So selecting a name, cast the content from the assembly files and joining on assemblies and so forth. And there you get the name of the file and the source. And actually a better way to do that is return the results to text, execute the code again, and now if I scroll over here, I can see it's a little bit more convenient to see the complete contents there. And if this particular file had carriage return line feeds, this results to text makes it easier to see that. Okay, I'll go back to results to grid. Okay, and we'll look at the next one. So that's assembly modules. This lists the public classes within the assembly. So these class names should look familiar, define a number of stored procedures and user-defined functions and triggers and UDFs and so forth. And it also lists the different methods that are available within each of those classes. And then the code also shows whether the code modules return null when it receives null input. So you can see that setting right there. And then if I change the execution context, it lists that information as well. All right, then there's a couple of related catalogs here, sys.procedures and sys.triggers, that list all of the stored procedures, both transact SQL as well as CLR. And then sys.triggers lists the triggers. And then the last one is the sys.types, which lists all of the types available. And so these include all of the system CLR types as well as any custom types. So as you can see, the system catalogs have a wealth of information about the SQL CLR code that's currently deployed to a specific database. A useful SQL CLR troubleshooting technique is to view the assemblies that are currently in memory. An assembly may not be in memory even though it's deployed and its methods are registered. SQL Server loads assemblies as needed and then releases them to free up memory resources as needed. So it's often very useful to be able to see what's currently loaded into memory, particularly if you're debugging any kind of problems that seem to be more related to SQL Server than with your code. And here's some code that lets you examine that information. So as you can see, some information is coming from assemblies, mostly what's needed to identify the assemblies. And then it's doing an inner join on a system dynamic management view called CLR loaded assemblies. And then it matches on the assembly ID. If I execute this code, you can see that I currently only have a couple of assemblies that are now in memory. And it's a little bit strange. It'd be interesting to track this to see how and when SQL Server loads and releases different assemblies. But if I were now to go out and execute some code in some of the other assemblies, you could re-execute this code and see what's loaded into memory. One particular problem that this can help solve is if you're getting weird kind of errors, but it might be a problem that SQL Server is loading a wrong version of an assembly if you've updated the assembly without dropping the old version. So there's lots of things that you can do with this kind of information.